Good afternoon. Hello, student. Today we see our second lecture of Engineering Mathematics 3 of Laplace transform. So, definitely you have seen this shared screen. So, today the Laplace transform of some elementary function we see. So, for which the learning objective of today's lecture is by the end of this lecture, students should able to find the Laplace transform of some elementary function by using definition of Laplace transform. Okay. See, first, Laplace transform of k is 1 by s for s should greater than equal to 0. Suppose this s equal to 0, what will happen? Something upon 0 is a meaningless, so it has no meaning. So due to that reason, this s must be greater than 0. So we want how this Laplace of k is 1 by k by s, we see. So first the proof of this, by the definition of Laplace transform, L of f of t is equal to integration 0 to infinity e raised to minus st f of t dt. So here this f of t means this k. Here f of t is equal to k. Then this L of f of t means L of f of k is nothing but integration 0 to infinity e raised to minus st. This f of t should replace by k, and this k is a constant take outside. So only integration 0 to infinity e raised to minus st dt, and we know that the integration of e raised to ax dx is equal to e raised to ax by a. So using this formula, we have e raised to minus st upon minus s from 0 to infinity. Now that will be equal to this minus k by s take common, in bracket only e raised to minus st from 0 to infinity, and that will be equal to this minus k by s. When we put upper limit this t by infinity, so we get e raised to minus infinity minus lower limit e raised to t equal to 0 into something is 0, and this s should always be done equal to 0. But we know that e raised to minus infinity is nothing but 1 by e raised to infinity, that is equal to 1 upon what is by infinity, this is the infinity, so it is 1 by 0, because this e raised to infinity is infinity, so it is 1 upon 1 by 0. This is become 0 by 1, and that is equal to 0, means e raised to minus infinity is 0, right? We know that e raised to 0 is 1. These two formulae use here. Okay. So we get minus k by s, 0 minus 1. This minus into minus become a plus, and we get k by s, and therefore Laplace of k, that is k by s for s greater than 0. It means that k is a constant, means suppose we want to require Laplace of 1, so that is equal to, put this k equal to 1, means k equal to 1. So answer is 1 by s. Suppose we want to Laplace of 2, so that is 2 by s. Laplace of 3, that is 3 by s, and so on. So Laplace of k, or suppose in terms of Laplace of 1 by 2, it is so 1 by 2 upon s, whatever your constant put here, and we get the Laplace of 1, 2, 3, Laplace of 100, that is equal to 100 by yes, means k, right? So this is about this is an elementary function. Laplace transform of constant is a k. So now next is the Laplace transform of e raised to at. Okay, and the answer is 1 upon s minus a, and here also this s should greater than a means a should greater than a. Suppose s equal to a, so a minus a 0, so 1 upon 0 is infinity, right? So it should be equal to 0, no sorry, greater than equal to a. The proof of this Laplace transform is by the definition of Laplace transform. What is the definition? L of f of t is equal to integration 0 to infinity e raised to minus st f of t dt. Now here this f of t is what? E raised to at. So here f of t is equal to e raised to at. Then Laplace of f of t means we replace this f of t by e raised to at. In the formula also integration 0 to infinity e raised to minus st e raised to at dt. This is the value of f of t, and therefore we know that e raised to a e raised to b is equal to e raised to a plus b. So this is what then e raised to minus st plus at, that is equal to, we take minus common, so s minus a, also we take t common. So we get this e raised to minus s minus of s minus a t. So this, and again this is equal to, again by using this formula integration e raised to ax dx is equal to e raised to ax divided by a. So a is what here? A is this term, right? So e raised to this at, e raised to at, so e raised to at divided by a. Now again this 1 upon s minus a take common, in bracket only e raised to minus of s minus a into t, and the limits are 0 to infinity. So upper limit minus lower limit. When we put upper limit infinity, so we have e raised to minus infinity minus, when we put 0, so minus e raised to t is 0, 0 into something 0 means e raised to 0, and remember e raised to minus infinity is 0 and e raised to 0 is 1. Put these two value here, we obtain 1 upon minus s minus a or 0 minus 1, and this minus into minus become plus, and that will be equal to 1 upon s minus a, and therefore Laplace of e raised to at is equal to 1 upon s minus a, and this s should always greater than a. It means that suppose Laplace of we want to t means having a value 1, so it is 1 upon s minus 1. Suppose we want to require Laplace of e raised to 2t, so this is equal to what? 1 upon s minus 2. Suppose we want to find Laplace of e raised to 3t, so it is equal to 1 upon s minus 3. Similarly, suppose we want to find Laplace of half t, that is equal to 1 upon s minus half, and so on. Means we can find the Laplace of e raised to 1, 2, 2, 2, 3t, 4t, 5t, whatever your t. So using this formula, yes, I think you all understand this. Then we go for the next formula, that is Laplace transform of e raised to minus at, and that will be equal to 1 upon s plus a, and here this s should greater than equal to minus a. So the proof by the definition of Laplace transform, that is L of f of t is equal to integration from 0 to infinity e raised to minus st f of t dt. Here f of t is equal to what? F of t is equal to e raised to minus at, and then we put this e raised to minus at in the definition of Laplace transform. We obtain L of f of t means L of e raised to minus at means integration from 0 to infinity e raised to minus st e raised to minus at dt. This is your f of t, right? So again we use e raised to a, e raised to b is equal to e raised to a plus b, and in this form, in this example, e raised to minus st e raised to minus at, that is equal to e raised to, take minus common, this is s plus a e to t, right? And this will be equal to integration e raised to minus s plus a t dt. So to evaluate this integration, we have a formula: e raised to a t dt is equal to e raised to a t divided by a. So a is this term total, right? And therefore this integration equal to e raised to minus s plus a t divided by minus s plus a, and the integrations from 0 to infinity. Now here 1 upon minus s plus a take outside, which is the constant term, in bracket e raised to minus s plus a into t, and the limits are 0 to infinity. So now we put upper limit minus lower limit. When we put upper limit t equal to infinity, so we get e raised to minus infinity, minus when we put lower limit 0, then we get e raised to 0. And also we know that e raised to minus infinity is 0 and e raised to 0 is 1. Put these two values in this equation, so we have minus 1 upon s plus a into 0 minus 1, because e raised to minus infinity 0, e raised to 0 is 1. So this minus into minus become a plus, and we get 1 divided by s plus a. So this is the Laplace transform of e raised to minus at. Therefore Laplace transform of e raised to minus at is equal to 1 upon s plus a for s greater than minus a. So it means that suppose we want to find Laplace of e raised to minus t, so it is 1 upon s plus 1. Suppose we want to find Laplace of e raised to minus 2t, that is equal to 1 upon s plus 2. Suppose we want to find Laplace of e raised to minus 3t, so that is 1 upon s plus 3. Means we only change this a, change this a, change this a, change this a, and similarly Laplace of e raised to minus 3 by 2t is equal to 1 upon s plus 3 by 2. So in this way we can find Laplace of e raised to minus anything at, e raised to anything into t. Anything means this is the constant number. But the point, it may be you have understand this very well. So now we go for the next formula, that is Laplace transform of sine of at, and the formula is a upon s square plus a square, where s should be than equal to 0. By the definition of Laplace transform, L of f of t is equal to again integration from 0 to infinity e raised to minus st f of t dt. Now here f of t is equal to what? F of t is equal to sin t, and put this f of t in formula definition of Laplace transform. We have L of f of t means L of sin t means L of integration 0 to infinity e raised to minus at sin e raised to minus st sin at dt, and using this formula, by using e raised to at sin bt dt is equal to e raised to at divided by a square plus b square a sin bt minus b cos bt. So we obtain this. Now here a is equal to minus s and b is equal to a. Put this two value in this formula, we get this integration. that is e raised to minus st upon minus s square plus a square in bracket minus s sin at minus a cos at. Now put upper limit. So e raised to this t replaced by infinity. So e raised to minus infinity, right? Means e raised to minus infinity. So it will be 0. 0 upon something is 0, and this 0 into the whole term is again 0. Means when we put upper limit, we get 0. So before it, here what we do? Firstly we take this common, and after that this remaining term, and here we put upper limit 0 minus lower limit t equal to 0. So e raised to 0 minus s sin 0 minus a cos 0. But sin 0 is 0, cos 0 is 1. So this is e raised to 0 is 1. Is 0 1 0 minus 1 means this minus minus plus 1, and that is equal to a, this 1 into a minus a, and this minus plus a, and therefore we have a divided by s square plus a square. So this is the Laplace transform. Therefore Laplace transform of sin at is equal to a divided by s square plus a square. This is the formula. Means suppose we want to find Laplace of sin of t, means value of this a is 1 is equal to 1 divided by 1 square s square plus 1. Suppose we want to find Laplace of sin 2t, means value of a is 2. So a means 2 divided by s square plus 2 square 4. Suppose we want to find Laplace of sin of 3t, that is a is 3 divided by s square plus 9. Suppose we want to find Laplace of sin of root 3t, that is equal to a is what? Root 3 divided by s square plus root 3 square, and that is equal to root 3 divided by s square plus 3. In this way we can find our Laplace of sin of half t. Suppose we want to find this, it is 1 by 2 upon s square plus 1 by 2 whole bracket square, and that is equal to 1 by 2 s square plus 1 by 4. So this is the answer. So this is about the elementary function sin at, and the Laplace of sin at is a divided by s square plus a square. Now we see the next Laplace of cos at. On the similar way, it is s upon s square plus a square. In sine it is a, but in cos it is s. So by the definition, again similar way, L of f of t is equal to integration 0 to infinity e raised to minus st f of t dt. Here f of t is equal to what? Cos of at, and put this f of t equal to cos at in the definition of Laplace transform. We get L of f of t means L of cos at is equal to integration integration 0 to infinity e raised to minus st f of t means cos at dt, and the integration is this using this formula. Which one? Integration e raised to at cos bt dt is equal to e raised to at divided by a square plus b square into a cos bt plus b sin bt. Here a is equal to minus s and b is equal to a. In this formula, put a is equal to minus s, b is equal to a, we obtain this. Again here we take this 1 upon s square plus a square common, so the remaining term as it is, and the limits are also same, 0 to infinity. Now here when we put upper limit infinity, so t equal to infinity is what? E raised to minus infinity, but e raised to minus infinity is 0. Means this is 0. 0 into something is 0. So this 0 means total term equal to 0 minus put lower limit 0, so e raised to 0 minus s cos 0 a sin 0, but sin 0 is 0, cos 0 is 1, and therefore it is s 0 into something 0, 1 into minus s is minus s into this minus plus s, so 1 upon s square plus a square into s, and this is equal to s divided by s square plus a square, and therefore we have a formula Laplace of cos 80 is equal to s upon s square plus a square for s greater than equal to 0. It means that suppose we want to find Laplace of cos t, means 1t, cos 1t, that is s upon s square plus 1. Suppose we want to require Laplace of cos 2t, that is not here, s upon s square plus a square means 4. Laplace of cos 3t, that is s upon s square plus 9. Similarly, Laplace of cos 5 by 2t, that is s upon s square plus 5 by 2 whole bracket square, that is s upon s square plus 25 by 4, and so on. Using this formula we can find Laplace of cos 80. A should be any constant. So this is about the Laplace of cos 80. Now we see the next elementary function, that is Laplace of sine hyperbolic 80. Now there is only difference of this minus. In simple cos sine of 80 it is a upon s square plus a square, but hyperbolic 80 is s square minus a square, and this s should greater than equal to mod of a. Now here f of t is equal to sin 80, and we know that sin hyperbolic 80 is equal to e raised to 80 minus e raised to minus 80 divided by 2, this formula. And again Laplace of e raised f of t means Laplace of sin hyperbolic 80 means Laplace of this, and that will be equal to this 1 by 2 take outside, Laplace of this, that will be equal to, we separate Laplace because the linear property of Laplace transform, which will be learned in next lecture. So 1 by 2 L of e raised to 80 minus e raised to minus 80, but sometime before we have seen e raised to 80 is equal to 1 upon s minus a, and L of e raised to minus 80 equal to 1 upon s plus a. Put these two value here. So 1 by 2 as it is, Laplace of e raised to 80 is 1 upon s minus a minus Laplace of e raised to minus 80 is 1 upon s plus a. And therefore after taking cross multiplication, this into this into this into this, so we have this minus, sorry, plus s minus s get cancelled, a plus a 2a, this two get cancelled, so we have a upon s square, because again we use here a minus b, a plus b means again use a minus b, a plus b is equal to a square minus b square. Here this, from this step we have a square minus a square using this formula, and we have a divided by a square minus a square. This is the Laplace transform of sine hyperbolic t, and therefore Laplace of sine hyperbolic t is equal to a divided by s square minus a square for s should be greater than equal to mod a. And we see the next example, that is Laplace transform of cos hyperbolic 80, that is s upon s square minus a square Also for s should greater than equal to, sorry, greater than mod of a. Now here, what is your f of t? F of t is cos hyperbolic at, but we know very well that cos hyperbolic at is e raised to at plus e raised to minus at divided by 2, and therefore Laplace of f of t means Laplace of cos hyperbolic at means Laplace of this term. Right, everybody? Again, we take 1 by 2 common and the Laplace of this e raised to at plus e raised to minus at. Again, by linear property of Laplace transform, we separate it. So, L of e raised to at plus L of e raised to minus at. Again, we know that L of e raised to at and L of e raised to minus at is equal to 1 upon s minus a plus 1 upon s plus a, and this 1 by 2 as it is. So after again multiplication of these two, so we have s plus a, s minus a. Now plus a minus a get cancelled here. This yes, total 2 years, and therefore 2 years divided by this means 2 again cancel. We have s upon s square minus a square. Okay, and therefore Laplace of cos hyperbolic at is equal to s upon s square minus a square for s greater than equal to mod a. So this is about the cos hyperbolic at. Suppose we want to find Laplace of cos hyperbolic t. So means 1t, that is s upon s square minus 1. What is Laplace of cos hyperbolic 2t? That is s upon s square minus 4, because a square is 4, a is 2, right? So Laplace of cos hyperbolic 3t, that is s upon s square plus a square means 3 square, that is s upon s square plus 9. Similarly, Laplace of cos hyperbolic 3 by 2t, that is s upon s square plus minus, this is also minus, this is also minus, so minus 3 by 2 bracket square, that is s divided by s square minus 9 by 4, and like way. Okay, so in this way we find Laplace of sine. So I think in last we can't find the Laplace of sine one. So suppose we want to find Laplace of sine hyperbolic t. So formula is a upon means 1 upon s square minus 1. Suppose Laplace of sine hyperbolic 2t, that is a means 2 upon s square minus 4. Laplace of sine hyperbolic 3t, that is, this is in last slide. Actually it is 3 divided by s square minus 9. And similarly Laplace of sine 5 by 2t, that is hyperbolic, not sine, is the sine hyperbolic 5 by 2t, that is equal to 5 by 2 divided by s square minus 5 by 2 bracket square, that is 5 by 2 s square minus 25 by 4. So like in this way we can find Laplace transform of all function. And now next one is Laplace transform of t raised to n equal to gamma of n plus 1 upon s raised to n plus 1 or n factorial upon s raised to n plus 1, because this actually L of t raised to n is equal to n factorial upon s raised to n plus 1 if n is 0, 1, 2 and so on, and L of t raised to n is equal to gamma of n plus 1 upon s raised to n plus 1 if n is fractional. What do you mean by fractional? Half, 3 by 2, 5 by 2, right? And where this gamma of n plus 1 is equal to, this is the formula, n factorial, right? So gamma of z or n equal to what? Gamma of n equal to 0 to infinity e raised to minus t, t raised to n minus 1 dt. That is equal to gamma of n minus 1 factorial. So, this is the formula. We take the examples. Laplace of t raised to half is equal to gamma of n is what? N is 3 by 2. So what is the formula? 3 by 2 plus 1. So gamma of 3 by 2 plus 1 upon s raised to 3 by 2 plus 1. But remember, gamma of 3 by 2 plus 1 equal to, using this formula, it is 3 by 2 gamma of 3 by 2. 3 by 2 gamma of 3 by 2. Again this 3 by 2 as it is, this 3 by 2 split into 1 by 2 plus 1. See, it is again 3 by 2. So again same use, 3 by 2, 1 by 2, gamma of 1 by 2. It is 3 by 4 and gamma of 1 by 2 is under root pi value. Since gamma of 1 by 2 equal to root pi is the value, remember that. So see, so and this is s raised to 5 by 2, this one is what, it will be equal to 3 by 2 into 1 by gamma of 1 by 2, this is 1 by 2, so we have 3 root pi by 4 s raised to 5 by 2, because gamma of half equal to under root pi, right? So this is about this. Now in the similar way, we find t raised to 3 by 2 equal to 3. Therefore, t raised to 3 by 2 equal to 3 root pi upon 4 s raised to 5 by 2. And similarly, we can find t raised to 5 by 2 is equal to 15 divided by s under root pi divided by s raised to 7 by 2. Now this is for exercise to you. So, and t raised to 3 means what? 3 factorial upon s raised to 3 plus 1. That is 3 factorial means n factorial means, or 5 factorial means 5 into 4 into 3 into 2 into 1. 10 factorial means 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. In this way, this is the 6 divided by s raised to 4, right? And suppose again, suppose we want to find Laplace of t raised to 7, that is 7 factorial upon s raised to 8. Suppose we want to find Laplace of t raised to 9, it is 9 factorial upon s raised to 10. Means here we increase 1 power of s. So next are some important formulae. That is, Laplace of 1 is 1 by s, Laplace of k is k by s, Laplace of e raised to at is 1 upon s minus a, Laplace of e raised to minus at 1 upon s plus a, and using these two formulae we obtain this. Also using this k by s we obtain this, right? So these are important, these are the more general, and these are the particular case. Okay, so Laplace of sin at a upon a square plus a square. Next, Laplace of cos at is s upon s square plus a square. Then Laplace of sin at is a upon s square minus a square. Laplace of cos hyperbolic at is s upon s square minus a square. Laplace of t raised to n equal to gamma of n plus 1 upon s raised to n plus 1 if n is fractional, and t raised to n Laplace of t raised to n is equal to n factorial upon s raised to n plus 1. And the most important formula is gamma of n plus 1 equal to n factorial. Similarly, Laplace of t is 1 by es square. And are the particular case of this. So today I think it will be okay. So in we see in next lecture the properties of Laplace transform. Okay, thank you all.